Do you really know what your AI is up to? Are you keeping track of what it's doing across time? Are you logging its outputs, and where are you storing those outputs? And can you visually see what it's doing at a quick glance? In today's video, we're going to look at how you go about doing this. I'm going to start with a very basic example. I'm going to be using Vercel SDK here with the Langfuse API. All right, let's just jump in. I'm going to be using a basic example to start off with. I'm using the Vercel AI SDK here. I'm just enjoying TypeScript, and that's what I'm going to focus mainly on this channel. It's mainly TypeScript with AI. So in this one, we've got a basic Vercel call. It's just asking our agent here, invent a new holiday, describe its conditions, and then we're going to give an output. So a very simple way of running, and I'm just going to use bun here to call this function, and then I'm going to run it. What's nice is it's just going to run. You'll see here we're generating a Langfuse connection, and then it will log everything through. So we can see the first Sunday of April. And the purpose is Harmony Day. All right, so it's really great. We've got our output here in our console, but so we clear this now. We can't remember what our AI agent did. Imagine you're running 100 of these. How do you keep track of that? Well, you probably could put it in a database, but then you might not know what was the trace of all those calls if you have a multi-step, which we'll go into a bit later. So this is where Langfuse comes in. So in this example, I'm using Langfuse, and this is generally what the UI looks like. You can actually come here, you can see your... All right, so in this example, I'm actually using Langfuse, so let's have a quick look at it. Here's Langfuse just on the screen. So one thing you'll note is it's quite nice. You can see the traces, how much your model costs for it actually right now. And if you have any evals, they'll also pop up here in terms of the score. And we can see traces by time, model costs, we can do by units by model. At the moment, it's only GPT-4o, and units by type. Very awesome. But let's go to our trace that I was talking about earlier. So we can click here and we can actually see this is the trace I was doing earlier. I asked it to invent a new holiday with transitions, and we can see the output. We can even see metadata, which I didn't cover before. But if we go back to our code, we can see it has metadata, and we're using keeping track of that. This is quite handy because you might be doing multiple steps in a workflow, and you might want to keep track of maybe the user ID, maybe user preferences or anything like that, and that's all captured and logged for you. And you can also add tags and things like that to help sorting data later easier. So that's our first example. Very simple, not too much. Let's go to streaming. Just to touch briefly why streaming is so important. If you're building any AI chat app, you might want to think about streaming because the user experience is a lot better. The user doesn't have to wait 24 seconds for the whole call to be done. They'll get some data at a time. And streaming is a bit more of a different way that you have to program for it, but you also should be logging what's actually happening for the streaming. In this case, it's very much similar to our previous one. The only difference is we're using the stream text from Vercel SDK. I'm actually going to change this for mini, just to show that the model is going across. And we're just doing a basic, we got no metadata on this one, so we shouldn't see that, and we'll just run that. And this is just basic streaming up. All right. So we'll give it a second, and we can see it streaming. So you can see how quickly that was. It's really giving us our output immediately, and then it finished. But this is not really coherent for us because we're just outputting it by the chunk. We could wait till it's finished and then output it. But what's nice is this is all logged for us. So if we go back to our traces now, we can see our new one, which is the basic stream log. And what's nice is we can actually see the full text here that happened, the prompts, and we can see there's no metadata this time. It's just got the AI prompt format, and that's it. And we can also check our dashboard to see if it shows row mini, and there we do. And we can see the row mini there, so we can see the difference in costs very easily for us. Great. All right, so let's move on to the next example, what we call a multi-step. We're going to use some tool calls. So we're actually going to use an agent here. Essentially, we're going to just give it a complex math problem, calculating what is the fare of the taxi. So let's just quickly go over this. We're telling it you're solving maths problems and step by step. Use the calculator when necessary. The calculator can only do simple additions, subtractions, multiplications, and divisions. Make sure you calculate answering within the calculator, break down the problem into smaller steps, use the calculator to calculate the answer for each step. Try to do at least 3 steps. Never assume that you can do the calculations. Only use tools provided to get the answer. Use the tool to provide your final answer. So there's a lot going on here. We're trying to tell the LM never to assume, because LMs aren't really that great at math. Sometimes they hallucinate, so we'd rather just trust our calculation tool so it can get a correct answer. And then we're telling it, hey, you're going to have to use a tool to do the response back in. So let's go over the maths problem quickly. A taxi driver earns $9,461 per hour work. He works 12 hours a day, and in 1 hour he uses 14 liters of petrol with a price of $134 for 1 liter. How much money does he earn in 1 day? Think step by step and calculate each step with the calculator. Make sure to deduct the fuel costs from earnings. Use a tool call for total earnings, then total fuel costs, then tool for profits. So we're asking it for quite a bit there, and we're hoping the agent can actually go and calculate all of this for us without us manually telling it how to look about it. So here we're just defining our tools. This is another reason why I really like the Vercel SDK, is just how the tool calls is pretty much just a function. So anything in here, this execute, becomes a tool. It's very good for wrapping and just code experience and all in general. So we've got our calculate tool, very simple. It's just doing a math equation with the expressions given to it. And we're just giving it a description for evaluating mathematical expressions. Very simple. If we were having issues with the tool call, maybe the LM wasn't giving us the best parameters for this, we'd update the description and maybe give it a few examples to pass through. And that's just something you should know. Create answer tool. So this is just like the tool for providing the final answer with explanation. So here we can see steps, calculation, reasoning, answer, explanation. So this is what we're hoping the our agent will use for the final tool call. All right, so let's go here. We're starting our logging. We've defined our tools here, and we're passing it to our agent here. One thing to note, this is a generate text, but it has a max steps of 3. So I actually want to change this to 5 here. So what does this mean? The agent doesn't really get it on the first 3 steps. It can do it another 2 steps before it has to exit. And this way we can make sure it's getting the right amount of tries to get to the answer we want. We're doing auto here, so auto is not really the required. Auto just allows LM to choose if it needs to use a tool call or not. In Vercel SDK, you can actually make this required, and that means it has to always use the tool call each time it iterates, and it will never actually just generate results by itself. But you have to handle that differently. All right, so we've got our metadata there, and we'll just call out the problems here something. All right, so we have everything there. This to next tool call, and this one is, I think, just this multi-step. Yeah, let's make sure that was multi-step. All right, so we're going to run this and see how well our agent does. So we can see it did 3 tool calls as we expected, and it actually gave us our final answer too. All right, but this is where the logging becomes very useful, because now we can actually see what was the time difference between the tool calls and actually giving us the answers. We can actually drill down. So in here we can see we've got the system prompt here, how it's going to use, and then the prompt of what it should do. What is the query coming in? And we can see the output steps. We can see step 1, it did this calculation first, that 1 second, third, and then it provided us answer. And we can see like our metadata there, which is awesome. And we can also see which the latency was 4.8 seconds, and the cost was negligible. But maybe we want to see a little bit more on the timeline on this. How did it actually look in terms of the tool calling? So we can see the tool calling was super quick. It was next to nothing. So it was pretty much instantaneously for the tool calls. But we can see the generation steps is actually where it took most of the time. So the first one to just understand what were the queries that it was going to run to each tool call, and then give it back that was coming through. So we can see here, that's the answer, and this is see if it, so here we can see it actually it shows the tool calls that was happening for the assistant. So it actually has what was it was asking for, and we can see the result was also given to it, so then it could actually use that to generate the final answer that we asked it, which is great, and which is right. So that's very useful. So we can actually track to see what's actually happening